my friends, now we are going to start our new chapter, that is the gear measurement. So, before going to start about the gear measurement, just let us know that what is gear. So, generally the gear is a tooth wheel which meshes with another tooth wheels to transmit power or motion from one shaft to another. So, I am having two shafts and I am having the gears. So, one gear will rotate, so that either another gear will rotate or sometimes both are rotate. So, what will happen, these motions will transmit to that another shaft. So, they have a advantage over frictions and belt drives in that they are positive in action, a feature which most machinery require. In order to have perfectly uniform relative motion between driving and driven shaft, it is essential that both gears be of perfect geometrical form. So, you see I am having two shafts. So, one shaft is rotating and that is rotating the another one, or maybe from smaller to bigger or maybe the bigger to smaller. Not only that, we can vary the speed also. So, one is rotating into the high speed. So, if I increase its diameter, then if I put the smaller one, so automatically the speed will reduce or maybe the speed will increase. So, that depends is upon how much speed is required. Not only that, it is always into the parallel position, sometimes it is in these particular positions also that it can rotate. Hence, during manufacturing the inspection process is included to ensure high degree of accuracy of gears. What are the functions of gears? First one is the power transmissions, second one is the change of rotational speed and torque, and the third one is the maintain constant speed ratio. So, now come to the gear terminology. Let us know in depth about that gear. So, what is pitch circle? It is an imaginary circle which by pure rolling actions would give the same motions as the actual gear. So, now I am having the driver means it is the engine. So, it is rotating and whichever it is rotating, that is known as the follower. So, this is the pitch circle over there in these particular cases. So, where it is meeting at the center. Next, pitch circle diameter or maybe the pitch diameter, it is the diameter of the pitch circle. The size of the gear is specified by the pitch circle diameter. Just to remember this point, the size of the gear is specified by the pitch circle diameter. Then come to the pitch point. It is a common point of contact between two pitch circles. So, here in this particular case you see the common point, okay. So, where it is actually meeting each other. Pressure angle or angle of obliquity. So, it is the angle between the common normal to two gear teeth at the point of contact and the common tangent at the pitch point. It is usually denoted by phi. The standard pressure angles are 14.5 degree and 20 degree. Next, come to the addendum. So, it is the radial distance of a tooth from the pitch circle to the top of the tooth. So, this is known as the addendum circle over there. So, this is top of the tooth. So, this is the top of the tooth. Okay. Then come to the dedendum. It is the radial distance of a tooth from the pitch circle to the bottom of the tooth. So, this is the dedendum. So, this is the bottom part over there. Next, addendum circle. It is the circle drawn through the top of the teeth and is concentric with the pitch circle. Dedendum circle, or sometimes we are calling it as a root circle also, it is a circle drawn through the bottom of the teeth. Next, come to the circular pitch, or in short generally we are calling it as a PC. It is the distance measured on the circumference of the pitch circle from a point of one tooth to the corresponding point on the next tooth. It is usually denoted by PC, as I told already. So, circular pitch PC is equal to pi d by capital T. So, where capital D is the diameter of the pitch circle and capital T is the number of teeth on the wheel itself. So, now this is the circular pitch over there. Two gears will mesh together correctly if the two wheels have the same circular pitch, then the matching will be proper. Next, called the diametral pitch, that is PD. It is the ratio of number of teeth to the pitch circle diameter in millimeters. Diametral pitch PD is equal to capital T by capital D, that is equal to pi by small p c, where same capital D is the diameter of the pitch circle and T is the number of teeth on the wheel. Next, come to the module small m. It is the ratio of pitch circle diameter in millimeters to the number of teeth. So, small m is equal to capital D by capital T. Then come to the clearance, because if we do not put the clearance, so high friction will be generated and there is a chance that gear teeth can break. So, that is why you are giving certain kind of clearance or maybe the tolerance value over there. So, it is the radial distance from the top of the tooth to the bottom of the tooth in a meshing gear. A circle passing through the top of the meshing gear is known as the clearance circle. So, in this particular case you can understand the whole thing over there. So, now we are having that circular pitch, we are having the addendum, we are having the dedendum, this is known as the addendum circle, this is known as the root of or maybe the dedendum circle over there. Now, this is the pitch circle over there, and now we are going to put the clearance value over there. So, here you can see that clearance or maybe the working depth circle. Now, come to the total depth, it is the radial distance between the addendum and the dedendum circle of a gear. So, maximum to the minimum, it is equal to the sum of the addendum and dedendum value. Now, what is the working depth? It is radial distance from the addendum circle to the clearance circle. It is equal to the sum of the addendum of the two meshing gears. Now, come to the tooth thickness. It is the width of the tooth measured along the pitch circle. So, now when we are seeing this one is known as the tooth thickness over there. Now, tooth space, it is the width of space between the two adjacent teeth measured along the pitch circle. So, now we are having that tooth space. Tooth space is this one and tooth thickness is this one. This is the thickness of the tooth and this is the gap in between the two gears, that is known as the tooth space. Backlash, it is the difference between the tooth space and the tooth thickness as measured on the pitch circle, that is known as the backlash. Then face of the tooth, it is the surface of the tooth above the pitch surface. So, this is the face width and this is called the face over there. So, face surface is means that the surface generally we can see from the outside itself. Then top land, it is the surface of the top of the tooth. So, this is the topmost surface over there, that is known as the top land. Flank of the tooth, it is the surface of the tooth below the pitch surface. So, this is the flank, this zone. Face width, it is the width of the gear tooth measured parallel to its axis. Then path of contact, it is the path traced by the point of contact of two length from the beginning to the end of the engagement. So, that is the path of contact. Length of the path of contact, it is the length of the common normal cut off by the addendum circles of the wheel and pinion. Arc of contact, it is the path traced by a point on the pitch circle from the beginning to the end of the engagement of a given pair of teeth. The arc of contact consists of two parts. Arc of approach, it is the portions of the path of contact from the beginning of the engagement to the pitch point. Arc of recess, it is the portions of the path contact from the pitch point to the end of the engagement of a pair of teeth. Simple, when this is touching, that is the approach, and when it is leaving, that is the arc of recess. Now, forms of teeth. So, there are mainly two types of profiles are used in manufacturing of gear teeth. What are those? One is called the involute profiles, another one is called the cycloidal profile. So, what is involute profile? Involute is defined as the locus of a point on a straight line which rolls around a circle without slipping. So, in this particular case you can understand easily. What is cycloidal profile? It is the curve traced by a point on the circumference of the circle which rolls without slipping on a fixed straight line. So, like this way. Cycloid gear tooth profile is based on the epicycloid and hypocycloid curves, which are the curves generated by a circle rolling around the outside and inside of another circle respectively. So, this is the difference, that how we are forming the teeth. Now, come to the classification of gears. So, generally gears are commonly classified according to the positions of the axis of the shafts between which the motion is to be transmitted. Generally, there are types of gears on the basis of orientation of shaft axis. If we divide, so it will be three. First is parallel, intersecting, non-intersecting and non-parallel. So, when you are talking about the parallel, first one is called the spur gear, then helical gear and the rack and pinion. If we talk about the intersecting, that is the bevel gear. If we talk about the non intersecting and non parallel, then worm and worm gears, and last one is the spiral or maybe the skew gear. So, now what is spar gear? If the teeth of the gear wheels are parallel to the axis of the wheel, the gears are called spar gear. They transmit power from one shaft to another parallel shaft. You see, they are mating front to front. Next come to the helical gear. In helical gears, the teeth are inclined to the axis of wheel. Their gradual engagement makes them operate much smoothly and quietly than the spar gears. So, this is the image. So, single helical gears, here is the double helical or maybe the herringbone gears. So, both sides the angle is different, gear direction is different. Now, come to the rack and pinion. It is a special case of spar gear in which one gear is having infinite diameter called the rack. This is the rack, and they are used to convert the rotation into linear motion. So, pinion. So, when it will rotate, so automatically this rack will move forward or maybe the backward positions. Now, come to the bevel gear. So, teeth of bevel gear are cut on conical surfaces. They are useful when direction of the shaft's rotation needs to be changed. So, from these directions we are changing these directions, rotation of the shaft. Bevel gears are generally used to transmit power at perpendicular direction. Worm and worm gear, it is a gear arrangement also known as worm drive, in which a worm meshes with a worm gear. So, in this way this is known as the worm and this is known as the worm gear. So, when it will rotate, so automatically this will rotate. They are used when large gear reductions are required. Spiral or skew gear. Spiral gears are also known as crossed helical gears. They have high helix angle and transmit power between two non intersecting non parallel shafts. So, one shaft is in this direction, one shaft is in this direction. So, any directions we can change the movement. Now, come to the measurement of gears, then how we can measure that about the gear teeth and all the details. So, the inspection of the gears consists of determining the dimensional accuracy during manufacturing using the following methods. First one is the general tests. What are those? Gear profile inspections like involute measuring machine, and the second one is the rolling gear test, that is known as the Parkinson gear tester. And the second one, measurement of individual elements like measurement of gear tooth thickness. There are three components, one is gear tooth vernier method, constant chord method, and the third one is the base tangent methods. And then measurement of pitch diameter and the tooth spacing, and the measurement of the gear pitch. So, these all are the different kinds of measurement techniques. So, first let us discuss about the general tests. So, when you are talking about the involute measuring machines, in this method the gear is held on a mandrel and the circular disc of same diameter as the base circle of gear for the measurement is fixed on the mandrel itself. After fixing the gear in the mandrel, the straight edge of the instrument is brought in contact with the base circle of the disc. Now, the gear and the disc are rotated and the edge moves over the disc without slip. The stylus moves over the tooth profile and the error is indicated on the dial gauge itself. So, now you can see now plunger movement. So, this can go forward or maybe the backward directions. So, when it will touch from here, then automatically it will go like this. So, automatically you can see the reading over there. So, by seeing the stylus reading, so simple you can do the normal general test over there. Now, come to the rolling gear test. It is a popular gear testing machine used in metrology laboratories and the tool rooms. The gear being inspected will be made to mesh with a standard gear, generally known as the master gear, and a dial indicator is used to capture the radial errors. So, simple I am having the one standard gears and then my gears will match, and then there is any deflections. So, that means there is some kind of problems. This test is generally performed on a most commonly used machine, Parkinson gear tester. Working, this test is used to detect any errors in the tooth form, pitch, concentricity of pitch line. When two gears are in mesh with each other, then any of the above errors will cause the variation of center distance. So, in this particular case you can see we are having that sliding carriage over there, this is the scale, this is the rest tables, and we are having the dial indicator. Now, two gears are matching properly. Okay. If that will not match, so what will happen? This will try to shift. So, in this particular case your dial indicator will change the value or maybe it will be deflected. Now, how much shifting is taking place, that you can get it from this particular scale. So, radial variations of the gear being inspected are indicated by the dial indicator. The variation is plotted on a chart or graph sheet which indicates the radial variations in the gear for one complete rotation. Now, measurement of the individual elements, like measurement of gear tooth thickness, gear tooth vernier method. First one, this method uses gear caliper to measure gear tooth thickness. Gear caliper has two vernier scales, one horizontal and the other one is the vertical. So, you can see this is the horizontal vernier and this is the vertical vernier. So, this is the combinations of actually two vernier scales. Horizontal vernier scale reading gives the chordal thickness, that is GC, and the vertical vernier gives the chordal addendum by measuring positions of a blade which can slide up and down. Working principles. So, in this particular case, first the blade position is set to a value equal to the addendum of the gear tooth and locked into position with a locking screw. The caliper is set on the gear in such a manner that the blade surface snugly fits with the top surface of the gear teeth. So, now you can see that it is rigidly tightening your gear teeth. The two anvils are brought into the close contact with the gear and the chordal thickness is noted down on the horizontal vernier scale. So, this will give you this value. The theoretical value of GC can be found out by considering one tooth in the gear and it can be verified. Theoretically, GC is equal to mz sin 90 degree by z. So, how to then from this particular case HC is equal to mz by 2 into 1 plus 2 by z minus cos 90 degree by z. So, GC chordal thickness of gear tooth along pitch circle, HC chordal height, m is the module, z is the number of teeth on this particular gear. So, by theoretically also we can measure and we can check the results with this test. Next is called the constant chord method. This method of checking gear tooth thickness measures the tooth width at the points of contact of a symmetrically placed close meshed rack. The length of chord AB is constant for all gears of the same module and pressure angle is irrespective of the number of teeth. A single calculations and comparator settings will suffice when checking a set of meshing gears with different numbers of teeth. It is an efficient method for measuring a large number of gears each having different number of teeth, but the same module. So, in this particular case we are going to measure by applying the constant chord methods, right. So, how we are calculating? The length of the constant chord AB is given by, so this one first we are going to measure this one. So, C is equal to AB is equal to pi by 2 m cos square phi and chordal height is given by small d is equal to small m into 1 minus pi by 4 cos phi sin phi. So, from there you can measure the C value and the D value. So, this is your D and this is your C. So, these two value easily you can measure, where m is nothing but the module and phi is the pressure angle of that particular gear. Now, next one is the base tangent method. So, in this case tooth thickness is measured by measuring the chordal distance over a number of teeth by using a tooth span micrometer, also called a flange micrometer. The base tangent length is the distance between the two parallel planes which are tangential to the opposing tooth flanks. So, base tangent length generally known as the span width across S number of teeth for a involute gear is given by, so this one we are going to measure this Ws value. So, Ws is equal to mz cos phi into tan phi minus phi plus pi by 2 z plus pi s by 2 z. So, where m is the module, z is the number of teeth, phi is the pressure angle, s is the number of tooth spaces in Ws. Tables for the span width for given values of module, number of teeth and pressure angles are used for the faster inspections. So, this is the techniques, you see directly we are getting the value, it is something like that 13.763. Now measurement of the pitch diameter, this is the very important one. So generally the pitch circle diameter and tooth spacing of a gear is measured by inserting cylinders, generally known as the plugs, in the tooth spaces so that their axes lie on the pitch circle. The cylinder or maybe the plug diameter can be found by considering a rack in mesh with the gear. So now cylinder plug diameter is given by PQ is equal to pi m by 2 cos phi, where m module and phi is the pressure angle, that is the normal one. So simple, I am having this cylinder, I am inserting it, and then I am, if I know this diameter over there, so easily I can make the measurement. But some cases what happened, that exactly whether detecting these particular 2 points is sometimes difficult. Note the plug size remains the same for all gears having the same pitch and pressure angle. A correction will again have to be made in this plug size for the backlash. Now working principles, if a gear has an even number of teeth, cylinders can be placed in diametrically opposite tooth spaces and measurement taken over them. So you see one is here and another one is here. So this is the measured readings over there, this is the cylindrical plug and this is the pitch diameter over there. So the pitch diameter is obtained by subtracting one cylinder diameter from this particular measurement. So easily we can measure. If a gear has an odd number of teeth, gears with an odd number of teeth can also be checked for pitch diameter by the 2 cylinder methods. So in this method a calculation is needed to find the pitch diameter. Next, measurement of the gear pitch. Pitch is the distance between corresponding points on equally spaced and the adjacent teeth. These two types of instruments that are usually employed for checking pitch are pitch measuring instrument and the pitch checking instrument. So what is pitch measuring instrument? So you see, so simply we are having that dial indicator and this is, of course it can go up and down motions. So wherever it will touch, if it will come over here, so automatically it will come down up to this one. So this will give you the value over there. So these instruments enable the measurement of chordal pitch between successive pairs of teeth. The instrument comprises a fixed finger and a movable finger which can be set to two identical points on adjacent teeth along the pitch circle. The pitch variation is displayed on a radial indicator attached to the instrument. Next one is the pitch checking instrument. So a pitch checking instrument is essentially a dividing head that can be used to measure pitch variations. The instrument can be used for checking small as well as large gears due to its portability. It has two probes, one is called the anvil, that is the fixed one, another one is called the measuring feeler, that is the movable part. Measuring feeler is connected to a dial indicator through levers. So simple, you can see we are having that anvil, that is the fixed one, and then another one is that measuring feeler which is movable. So automatically what will happen, simple, by touching that one is the fixed one side, another one I am just moving and then I am fixing and I am getting this dial indicator value. So how it is working, the instrument is located by two adjacent supports resting on the crest of the teeth. A tooth flank is butted against the fixed anvil and locating supports. The measuring feeler senses the corresponding next flank. The instrument is used as a comparator from which we can calculate the adjacent pitch errors, actual pitch and the accumulated pitch error. So this will give you this kind of informations. Now we have come to the last slide of this particular lecture. So in summary we can say that gears are the main elements in a transmission systems. Say simple, it can transmit the speed or maybe it can transmit the power from one shaft to another. So for efficient transfer of speed and power, gears should conform perfectly to the design profiles and the dimensions. During manufacturing, the gears are inspected to ensure high degree of accuracy using different methods. All methods comprising general testing methods and measurement of different elements of gears have already been discussed in this particular lecture in elaborate manner. Thank you.